try this one. Let's see. All right. So first of all, there's some stuff that I'm not putting up on the screen because it's like just doesn't fit. The beginning of this problem says urea H2NCO NH2. So this is urea. You guys understand urea is like a main part in urine? Okay. Just by the way, I got to tell you this because this used to be something I teach in biology. Want to hear about the history of pee?
Sure.
Okay, here's the history of pee. Okay. Do fish pee?
Sure.
Fish do not pee.
You know?
They poop, but they don't pee. Okay. Peeing, what peeing is urinating, is getting rid of nitrogen waste. So it's the breakdown of proteins. When proteins break down, you got to get rid of them out of your body because they're toxic. And the way that fish do it is they secrete it right through their skin. Okay, they secrete ammonia. And any guys that have ever had a fish tank know you have to keep track of the nitrate levels, right? But they can secrete it right off their skin. If you put ammonia on your skin, it would hurt your skin. Why doesn't it hurt the fish? It's swimming in water. So what happens as soon as it secretes it?
Just gets washed off.
It just gets washed off, okay? Now eventually, life came onto land, right? And that process wouldn't work anymore. So what you had to do was find a way to get rid of your nitrogenous waste. And what animals like us did is they developed a bladder, a place to store the liquid, okay, until you were ready to get rid of it. But you also had to store it in a less toxic form. So you store it in the form of urea. The problem is that when you make urea, it's diluted with a lot of water. So we, as humans and a lot of organisms on land, demand a lot of water, okay? But then animals learn to fly. Do birds pee?
No.
Birds don't pee. You know how they get rid of their nitrogenous waste?
Poop.
Nope.
They throw it up.
Nope. Getting close though. It does come out of their head.
Oh, they smell it out.
Yeah, it's like it comes out of their noses. And what it is it's uric acid. So they've taken ammonia, is what fish get rid of. We spend some energy to make urea at the cost of having to carry it around and having some more water demands. And then birds got the problem because they can't carry the water around. Why?
Because they fly.
Because they fly, and if they were to fly, they wouldn't be able to fly if they were carrying all this water weight. So what they do is they spend a little more energy and take the urea and make it into uric acid, which is a salt. And sometimes you might see some birds in like nature videos like kind of sneezing and all this salt comes out. That's their nitrogenous waste. Yeah. The history of pee. Okay. So this is urea too can be used as a fertilizer and a lot of other things. It says here in the beginning, urea is extensively used as a nitrogen source in fertilizers. It's produced commercially from the reaction of ammonia and carbon dioxide. So again, back some time ago I showed you this reaction called the Haber process, and that was to make ammonia. Now ammonia is a precursor for fertilizers, and one of the types of fertilizers is urea. In fact, if you ever go into the plant store and smelled some fertilizer, it kind of has a urine-like smell. Okay. All right, so we're going to do a reaction here, and it tells you that you have ammonia gas at a particular temperature, a pressure, and it's telling you it's flowing at a rate of liters per minute. Okay, so that's kind of screwy at first. Then we read on, they give us a temperature and a pressure, and they give us liters per minute again, which is kind of screwy. But then when they say what mass of urea is produced per minute, basically I could say that's just 500 liters and that's 600 liters, because that's in a minute, right? So if I know for the ammonia, I know temperature, pressure, and volume, what do I know? Moles. And if I know volume, temperature, and pressure for the carbon dioxide, what do I know? Moles. And if I know the mole values for two things, what kind of problem is this? It's a limiting reactant problem. Okay? So what we need to do is first figure out how many moles of ammonia we have, how many moles of carbon dioxide we have, write down that moles have, compare them to each other, moles need. The limiting reactant's one where you have less than you need. Use your limit to get to your product. Sound familiar? Okay, so first guy up is Ronnie. Do something productive, Ronnie. Now, I would caution everybody here, maybe we should be very mindful of space because we got a lot of work to do. So if we start writing stuff really big and all over the place, we're never going to get this fit on the board. Yep.
So do fish drink?
I think fish get most of their liquid through what they eat. Because if you were to drink seawater's salty, and that actually would draw more water out of you.
Okay.
Yeah, like if you're floating in a boat you're out in the ocean, you have no water, you're better off not drinking the water, because you'll dehydrate quicker than if you were just to not drink anything.
So what should you do?
Right.
Pee.
If you can find a way to distill water, but with the sun or something, like if you had some seawater in a container and you had like a plastic bag, you might be able to like build like a little still, like if you made pot and you kind of like, what I would do, this is the way I would try and build it. If I had this stuff, I would take a pot like this and take another pot in here, okay? Fill this with seawater, maybe throw some rocks in there so this thing weighs down. And I'd take a piece of plastic, clear plastic, and drape it over so it's dripped here. And what'll happen is condensation will appear up here because of the sun, and the drops will come down and drop down in. That's what I would do. That'd be my MacGyver move. I never watched MacGyver. He's known for all that kind of stuff. Oh, Roddy, you didn't pick up on what I was trying to tell you. Okay.
Oh, I did.
So since the 500 liters per minute is the kind of confusing thing about this problem, the reason it shouldn't be confusing is because they're just talking about how much is produced per minute. So basically, we can ignore the per minute thing because it's going to just be 500 liters. You guys get that? If I'm telling you going 35 miles in an hour, how far are you going in an hour? Right. So if I tell you got 500 liters per minute, how many liters are there in a minute? So let's just go 500 liters.
So we can just take that off.
Yeah, because they're already saying per minute. So like if they said per 2 minutes, then I'd have to say 1,000.
What if one was a minute, one was an hour?
You'd have to convert, yeah. That's not gonna work. No, so let's go back to our equations again. Remember, the two equations you gotta know. One is this, and you wanna know moles, so N equals PV over RT. So we should be solving for N right now. I like the comment there. Makes sense. Okay, so let's see. No Peter Fresina today?
I saw him earlier.
I think he set up for now, so I'm pretty positive. He sent me an email and said he wouldn't be here, that's nice. Oh, you guys that weren't here yesterday because of funky schedule, did you guys have your labs turned in? Joe DeMarco. These are obviously on time, returning them. Yep. Everybody else? Yeah, Nick, you were absent, right? Thank you, Gary. Hey. That looked good to me. Okay, so you want to call somebody up else? Show us up to Liam. So Liam, you can either do that calculation or you can set up your other one. So let's see, 90, good? Volume 500. Only thing I'd say here is you should have a unit here. Liters.
What do you think one of these probably were?
Something like this, probably 20 points. Yeah. I gotta double check. I think I have it at 40, but I'll have to double check. It must be more. I can't remember now. Let me find it.
Yeah. So we just got to put it was like a lot.
I don't remember honestly. Oh sure.
I used to.
60.
I totally forget his name. Sometimes when I'm driving, I like to see
60, yeah. You guys hear Thomas Young flipped his car in?
Yeah.
Oh,
yeah.
yeah.
Yeah, it's actually.
Did he
Thomas
like,
Young.
what happened to his neck?
It says it hurts, but he'll be in school.
Or Thomas Young, but the kid from Vermont. Does he have that light bar? Yeah, he drives that Subaru.
That's urea.
Well, he was driving and snowplow ran him off the road and
No,
flipped
no
upside
two.
down.
Just the substance. That two will come in a minute.
I don't know. What
If they did, I don't know. We'll have to see.
They would have had to touch the car, because you
Who you calling now? Okay, so John, this setup, now here, one thing I'll be a little picky about too. Not too picky, but at some place in the beginning here, we should say what we're dealing with, so that might be helpful. But any which way, right? That's one way to keep track of it. Now let's stack these, right, because we're doing a limiting reactant. So I do the same thing for the CO2, yep.
Why are we using R here?
Because you're solving for moles, and whenever you're just doing the PVNRT to get moles at a single set of conditions, R has to be in there. So like, remember, this isn't a before and after condition thing on a contained gas. This is just, we know the pressure, volume, and temperature of a gas. If I want to know moles, then I need R as well.
When you know you don't have to use it.
Whenever it's on both sides of the equation, whenever it cancels out. Okay, so let's see. Now, what, is that just CO2 or N of CO2? Yes, Ronnie?
Oh,
And
and
I normally ever use what I had earlier. What I
Only when it's at STP. So if I were told you ammonia gas at STP occupies a volume of 500 liters, then you could go right to mole using 22.4. Yeah.
I got like negative 10 power.
Oh, I think that's wrong. 45 times 600 divided by 0.08206 divided by 496. Maybe that's what.
Oh, okay, I must have. And then will these two cancel? The
Yep.
2Ks?
And that's 1 over moles, which comes out to be moles.
Can we go to that decimal then? To keep it the same or what?
Yeah, that's fine. I would hate to be a big or unclear there, but it's just like we're kind of being not all doing all this all right to begin with, so. That's moles. Okay. You picking? Even before you do that, what did we just calculate? What we?
Oh,
Nope, not needs.
or 1.
Halves. There you go. Rough crack. Good job.
You get the 2 moles from.
Coefficients.
Oh, okay.
It's inevitable. Inevitable disappearance is inevitable. Yes.
Wouldn't it be NOCO2 all the way through? Like, it's 663.362 mole CO2. Wouldn't you do NOCO2?
No, we're turning this into each other right now. So we're taking CO, we're comparing these two things to each other.
Yeah.
So we're getting rid of CO2, we're going to NH3. Here we're getting rid of NH3, going to CO2.
But you made me write NOCO2 at the beginning.
No, I said N, I'm sorry.
Oh.
Moles.
NOC.
N of CO2.
Oh, they say
N of, like N of NH3. You see this here? N
Yeah.
NH3, yeah, I got you. I
Do you
didn't
want
see
me
it.
to do the other one?
If you want to.
Okay.
They can label what those things are.
Hey, Malik.
This one.
Yo.
What were you
You
doing?
want
Yeah.
R1 over that, N1 over R1 over T1 because you have to use a flow chart.
Yeah.
See now.
These are what we. These are what we. Well, told us what we have. So this is what we. Those are your halves.
This is going to be our. Good enough?
Yeah, but I'll bug you to do one more thing. Can you label the ones on the right need?
Sure.
I wouldn't mark anybody wrong if they didn't write have a need. I do that more for your help you.
Do we need to label the limit?
Uh,
The thing?
If you just pull the limit and show me the calculation, I'll know you know that's the limit. Okay, so what's next? Who's next?
You know what, I got screwed over Rob.
Yeah, it was nice. The park was closed though.
Was it?
Yeah. But they're like completely rebuilding it. The tabletop is huge.
Okay, alright, so now we take our limit, so let's rewrite our limit. Just rewrite your limit someplace, so there you go.
Oh. This is the only time that we see.
Okay, and now we want to turn that into the goals that we think we're going towards. So we can get rid of moles of NH3. You gotta be careful, you might run out of room here.
Big bro.
We've got one more thing to write. We want to turn it into moles of where we're headed. Now, where are we trying to get? Moles of
An hour?
urea. So let's put moles of urea up top.
What do you think the longest ride
Get that from coefficients.
What do you think the longest ride would be? It's like 2 minutes.
4 or 5 minutes for the very longest one. Yeah.
45 minutes a year.
You said there's places in Vermont where
I
yeah,
believe
you go up above the clouds.
Yeah, Vermont, there are definitely some.
Good. Okay. Who you
I
got
don't
there?
know why anybody would move from Vermont to Erie.
Thomas,
Yeah.
because he likes to wreck cars.
Okay, so in order to turn that into grams, what you gonna need, Nick?
Oh, it's kind of some grams.
Yep. Star grams, yeah.
How can you call sergeant?
That's just something I said one year, and everybody seemed to. I used to say molar mass, and I'd say it, and then one year I said star grams, and everybody seemed to learn it better. So I just stuck with it.
Why sergeant? Did you like mess up?
No, I just was making a chart, and I said I'll put a star here. A star is like an X. You know what I mean? Just being creative. Trying to be creative, I guess.
Do you have a periodic table?
Yes. Right here. Did you see Father's fact about that first Catholic school?
No.
I've been there.
Really?
It was the oldest Catholic school, first Catholic school in the New World. Or in the United States. No, because you had the N's and the H's separately.
Why not?
Call him out on his belt?
No, I was trying to inform.
Yeah, I'm busting him now.
Oh no. Isn't it silly belt day?
That's silly belt. You do realize Gary's in really good shape, so you probably do crap.
Yeah.
I know
was
you
trying to
wouldn't. I
inform.
know you wouldn't.
I mean, Hedwig does too.
I love messing with you.
That's why I tried to stay quiet about it.
I love you, Coach Monty.
Actually, I'm gonna say on the.
No, oh, wait. We're calculating it for the wrong thing. We need it for the H2, NCO, and H2, the urea. And H3's been canceled away, yeah. And the other thing is, I wouldn't use all those decimals. I just round the whole numbers. Save our volume.
So,
Three.
because there's an N here and an N here, is that?
2 N's, yep.
Yeah. They're too hot. If you hot, I don't like wearing the pants. He was on Instagram. That's his move. I want to get one that's really long, so like. Hey, he's got a super hot one. The ones at the back. Yeah, that they look like
Yeah, they have a couple of those in the basement.
He's not that great.
Is it
He
bad
hasn't
to
made it to
me?
the
Yeah.
in the basement.
Yeah, when Prep used to have a band.
In the basement.
Oh,
Yeah,
that's-
he's
yeah.
working at Georgia Southern. You think Marshall?
Marshall who?
Who?
I don't know that.
Did you come to Applebee's the other day? Oh, that was Brad. Never mind. You don't know Marshall.
That's it.
I think it's gonna be more than 50. 60. But you don't know
Oh, yeah. Who's my wife's sister? You already do. George is on. No, it's Joe's cousin.
And what would the unit speed?
Yeah, probably Yeah, I'll put him up too. He watched it.
Anybody confirm that number? Because that looks good to me.
Yeah, 60, yeah.
Yeah. 60, and that'd be like half of 50 would be 25. 25 times 1,100, that's like 25,000 more for that. 27,000 seems reasonable.
Yeah.
Obviously, yeah, it still says. Thank you.
So that might, does that change it?
It would a little bit. So we can double check that. So it's going to be 1105.6 divided by 2 times 60. And so it's going to be 33,160. So you see that, Nick?
Yeah.
33,160. So that's like what, 33 kilograms? That's like, I don't know, 70 some pounds, 80 pounds, 60, 70, 80 pounds. So it seems like a lot, but it's an industrial size thing. But that's every minute. So you know what I mean? So every minute